Hi, this is Miss Pollock, and I'm here to talk to you about a sample Newton's third law question. And this is the kind of question will be on your assessment. So I just wanted you to have an example of the expectations for that. So here we are. This question is asking, how does the force block A exerts on block B compare to the force block B exerts on block A? So I have two blocks moving at a constant velocity. I hope you remember that in order for something to move at a constant velocity, it has to have balanced forces. So first it says to draw an interaction diagram. So I have block B interacting with block A with the normal force. They're both interacting with the floor. It doesn't say there's no friction, so I'm going to put a friction force and a normal force for each block. And they're both interacting with the earth. So there's the interaction diagram. Now I'm going to draw the free body diagram. And I put this grid so you can put the size of the forces exactly how they need to be. So let's do block B first because it only has 4 forces acting on it, and that'll make it a little easier. So block B has a gravitational force of the earth on B, pulling it down, and it isn't going towards the center of the earth because of the normal force of the floor on B. Those are balanced because there's no change in motion vertically. Then block A is to the right of block B. So block A is pushing block B to the left. So that's the normal force of A on B. The forces have to be balanced because it's moving at a constant velocity. So that means my friction force is to the right, and that is the floor on B. So my forces are balanced. Block A has twice the mass, so that means its gravitational force would have to be twice the length. So that's the force, the gravitational force of the earth on A. And since there's no change in motion vertically, my vertical forces have to be balanced. So the normal force of the floor on A. All right, so we know that Newton's third law says that if two objects are interacting, those forces are equal in magnitude and opposite in direction. So if the force of block A on B goes to the left, then that means that the force of block B on A goes to the right. I also have a friction force going to the right, so I'm going to make my dot a little bit bigger so I can have enough room to put a friction force of the floor on A to the right. And as I said before, the forces are balanced. So the force of the hand, the applied force of the hand, which is to the right, will have to be twice as big as either of those other forces to the right. So the applied force of the hand on A to the left is twice as big as the friction force and the normal force. So if I look really carefully at my free body diagram here, I can see that my normal force of A on B is equal in magnitude in opposite direction to my normal force of B on A. So to answer the question, the force of A on B is equal in magnitude. Another word for that is size. Equal in magnitude and opposite in direction to the force of A on B. And this is called a force. There you go. Newton's third law. Have a great day.